Hello, here we are with the professor, and on this video we're going to be talking about inflection points. So, a point on the graph of a continuous function f where the tangent line exists and where the concavity changes is called an inflection point. Now, as you see here, these are tangent lines going through here at these points on the graph here. Through these functions is a tangent line, as you see, and it separates and shows where the function is concave upward and concave downward, as well as here concave upward, concave downward, concave downward, concave upward. These points where you see are inflection points where the tangent line are separated. So if we look at finding inflection points, this is how we do it. We want to compute f double prime of x. You have to find the first derivative and the second derivative. And then determine the numbers in the domain of f for which f double prime of x is equal to 0 or f double prime does not exist. And also determine the sign of f double prime to the left and the right of each number c found in step 2. And if there's a change in the sign of f double prime of x, as we move across x is equal to c, then we have this point, which c, and then you have f of c is that inflection point. As we go back here, this is like the critical point c and f what? F of c at that point. Now, let's do a couple of examples or go through a couple of examples. We want to find the point of inflection at x, at f of x is equal to x cubed. So f of x is equal to x cubed. This is a cube function here. And you can actually see where the inflection point is when you do the graph. So remember your library of functions, remember, in pre-cal, in those algebra courses? Well, f of x being equal to x cubed, it looks something like this. So look at that. That's where our inflection point is. This is concave upward. This is concave downward here, as you see in the typical examples on the board here to my right and to your left. However, let's look at this though. F of x is equal to x cubed. We want to take the first derivative, which is 3x squared. Then also continue on and take the second derivative, f double prime of x, which is equal to 6x. Now, we're going to set f double prime of x is equal to 0. And so we're going to solve for x. And as we see, x is going to equal to what? 0 right here. As soon as we find x, we must do what? We must take the value c and plug it right back into the original function, which is, in this case, x to the third. So we say f of 0 will be what? Will be 0. 0 to the third power of 0. So f of 0 is 0. So the inflection point is going to be right here at what? 0, 0. So this is how you do this example problem here. Let's go to example number 2. Problem number 2. Let's find the point of inflection at f of x is equal to x to the third minus 3x squared minus 24x plus 32. So we write this over again, and then we take the first derivative, and then we continue on and take the what? Second derivative, f double prime. And so the first derivative being 3x squared minus 6x minus 24. And then, of course, the second derivative is going to be what? 6x minus 6. And then we take f double prime and set it equal to 0. And then we factor out, of course, solving for x. We have to factor or, of course, use the quadratic formula. Here, when we solve for x, we come up with x is equal to what? 1. And then we take x is equal to 1 and plug or substitute 1 back into the original function, and as we did right here. And so we come up with f of 1 being equal to 6. So your inflection point for this problem is going to be what? 1 and 6, right at that point. This concludes the video talk on inflection.